Hello.
Hi, I'm Elle. I wrote part of the script and I made sarcastic comments throughout the video.
I'm Emma, and I helped write the script.
I'm Tyler. I was the artist and I did think memes.
Thank memes. I'm Alan. I voiced over the video and helped do things and filmer. We decided to do a Draw My Life for our project, so we're going to start out with our nebula formation. So we start out with a cloud of gas in space, like a super big one. Not quite a nebula yet. It becomes nebula by all those gas particles rubbing up against each other and exchanging electrons. So this creates charged particles. These charged particles will now attract to each other because of the electrostatic force and make one really big but little more dense cloud in the space called a nebula. The more atoms there are, the stronger the nebula's attraction to other gas will be. While we take a quick snack break, I will introduce our next stage, which is gravitational attraction. Now that we have a rough nebula, it starts contracting. When the nebula is formed, it is initially somewhat spherical. All dust particles that make up the nebula now have their own gravitational potential. Every atom is pulling at every other atom. The most intense directional pull is towards the center. This is because most of the nebula's mass is on the opposite side of the nebula from a given particle, which draws it towards the center. This center is also called the center of gravity because all of the matter is attracted towards it. As the makeup becomes less distributed, the nebula starts spinning faster, which takes us to the conservation of angular momentum. You see that all of our matter is now rapidly contracting. It is now that we experience a really fun part of physics. Stuff starts spinning at this stage. Well, to your eye, you probably can't see it quite yet, but I promise you it is spinning. The main reason this big cloud of gas is spinning is because of outside torques from nearby systems and stars. These torques are exerted via gravity, and it is causing it to rotate. As we get smaller and smaller, we get spinning faster and faster due to the conservation of angular momentum. When objects have a lot of mass outside of the center of rotation, they have a big moment of inertia, which basically means it has a lot of spinning momentum. So when all of this momentum transfers to a smaller object, such as a solar system or even a star, it spins really, really fast. This demonstrates the conservation of angular momentum. So now we have one really small spinning ball of matter. But how does that become a star? Gravity has a big role here. When a lot of the gas clumps together, it starts to become very, very dense. There's now another cool part of physics at work, the ideal gas law. As this ball condenses more and more due to gravity, the gas becomes very hot. That is because of the gas law. This gas law tells us that only two things in this equation can change: the pressure and the temperature, and they are directly related. As the pressure increases, so does temperature. This ball is very hot now. We can call this ball of gas a protostar. There is also a point where gravity and the pressure of the gas balance out, leaving it as a dead star forever to be in hydrostatic equilibrium. But if this ball of gas has enough mass, the gravity will eventually overpower the pressure of the gas and contract even more, throwing the temperatures way, way high. This is when ignition happens at around 15 million degrees Celsius. Be careful, it's not burning. This is when nuclear fusion begins. That means the gas gets so hot that it merges the elements inside to create new ones. Usually the fuel for these new stars is hydrogen and helium. Now we can call this a star. So when balls of gas get compressed, they turn into that. Right? They turn into that?
Yeah,
Uh-huh. Good job.
yeah. Fun.
Now for the fifth and final stage, we have coalescence of residual material, which is essentially the stage where the planets form. How do they form? Well, basically, the leftover material that floats around the developing star collides with each other to be creating chunks of bigger material which eventually become planets. This disk of material is called the Protoplanetary Disk. In this, Essentially, a giant game of Agario goes on, aka Coalescence. Now, you may be wondering, why are some of the planets made of gas, even though the gas does not like to be with each other? Well, that's because of a little something called the frost line. The frost line isn't an actual line in space, but it's the point at which something is so far away from the sun that it's super cold enough to freeze gas together. Now you see our completed solar system.